name is Gerald Hiebel from the University of Innsbruck, and I'm presenting the work that we did together with the University of Bochum and the German Mining Museum there, and with Zurich, with the University of Zurich and the Canton. And it's based on a common project, so I want to present here what we tried to do. And the data, linked open data with provenance for prehistoric mining archaeology. So it is about data that came from a project dealing with prehistoric mining archaeology. It's called a DACH project, D standing for Germany, Deutschland, A for Austria, and CH for Switzerland. And it's about prehistoric copper production. The German Mining Museum. In Austria, it's the University of Innsbruck. And in Switzerland, Canton of Grisons, the University of Zurich. And I want to show the data that these three institutions collected. And then I want to show the research questions that they put to these data. It's one main point is the prehistoric mining technology in the that was used in the Eastern Alps. And then there's the kind of the results of the project is a hypothesis of the know-how transfer within the Eastern Alps between different areas of mining, prehistoric mining production. And so we have this with the data, we have the technology, the hypothesis, how do we represent that in an integrated data approach. We are using data modeling, CIDOC CRM and Tesori. We're using semantic technologies and kind of what you can do, a first glimpse of what we want to do with this data, some GIS visualizations. So this is the lead through this talk. The project, we have three areas. We have the area of the Mitterberg, which is researched by the German project part. We have the area here in Schwarzbrixleck in the Lower Inn Valley and Kitzbühel, which is researched from the University of Innsbruck. And we have the Oberhalbstein, which is researched at the University of Zurich. This is all located in Austria and Switzerland. In Germany, the structure of the database, I don't want to go into detail, just to show that there are different approaches how to structure the data. They are having lots of data from mining activities. They have many projects around the world. And they structure about with finds, features, structures, and sites. And they have GIS infrastructure to do that. The finds have some relations to other Tesori, to other investigations. And what they are doing with their data, for example, is here we see the mining sites at the Mitterberg region in Austria, which is in Salisbury. Or what they do, they make analysis of their finds. In this case, these are slags. So these are the products that come out of the smelting process, and you can analyze them with different research questions. If you look at the database in Innsbruck, we started a database in 2007 because we had a big project in the University of Innsbruck integrating various disciplines, also from the humanities, history, and we had an Oracle database there, a GIS, ArcGIS in this case, and a content management system, SharePoint to handle our data. And what we did with this database, which was until 2011, for example, we displayed the research activities in the areas that were researched, and you see the humanities and the natural science, how they collaborated at the different research sites. In this DACH project, where we integrate now the data, this database was not used anymore, so we had a different representation. That just Excel sheets were used to document the sites and the finds at these sites. And in Switzerland, we have yet another structure of data. They have access databases, and they are coming access database structure coming from the canton, and then it was further developed in the project for the needs of this specific mining archaeology. And they are using Access and ArcGIS. So what they do, for example, also is site locating sites, showing the sites, different types of sites, looking at the altitude model and the site in relation to the sites, or making also analysis of the finds at the sites. So we see we have three different structures of data, often different purposes of what to do with this data. And now we look at the questions behind. What should be investigated in the project? And this is the prehistoric mining technology, and in specific the copper production, which starts with the mining, then comes the beneficiation of the ore, and then comes the smelting. And there are different technologies, different processes to do that in each of these areas. And then you have diagnostic structures and finds that tell you, okay, this is this kind of mining, that's that kind of smelting that was used. And in the end of the project, the idea was to learn more about the know-how transfer processes and the dynamics in time and space. How did it move on? How did the technology move within space and in time? So the hypothesis at the end of the project, which lasted until 2018, was that in the Middle Bronze Age at the Mitterberg started the smelting process, which is specified through specific structures and specific finds, because this was the first time this structure was found. It was called the so-called Mitterberg process, a specific way of smelting the material, of getting copper out of the ore. And then this process spread going into the late Bronze Age to Kitzbühel, Jochberg, to Upper Styria. And it spread further on into the start of the Iron Age to the Trentino, the Lower Inn Valley. And in the early Iron Ages come to the Oberhalbstein in Switzerland. So this is the hypothesis. And the question is now, how can we represent this with our data structures, with our integrated data? The idea is we have our material remains as a starting point. We have field work and analysis on the finds, on the structures. Then comes the documentation of this field work, of the material remains, which leads us to the interpretations of human activities. What happened at the archaeological times? And these interpretations give a new light also on the material remains that have been found. You can, with the interpretations, you see the things in a new light, making this a kind of a circle. We're using CIDOC CRM family of models to represent this research, which is used in Ariadne and as an ISO standard. We heard about it. In the core, it's the core model of CIDOC CRM, event-centric model. And in this project, we're using now the extensions for argumentation, CRMinf, for scientific observation, CRMsci, CRMarchaeo, and CRMdic for the provenance of digital documents. CRMgeo is used a little bit, not extensively yet, for the geometric information, which is in with the project. The idea of modeling is we have our material remains, which are modeled with CRM and CRMarchaeo, and we have the field analysis, the field work and the analysis, which are modeled with CRM Science. Let's take we have here furnaces as a material remains or rust bed slags. Then we had excavations at this place, and we had dendrochronology and 14C, C14 measurements. This was documented. You can trace the documentation with the CRMdic and CRMgeo extensions. And then we have interpretations on these things. And the interpretations are based either on the remains, on the field work, or on the documentation. And this relation from the interpretation back to the remains or the field work gives us the provenance of the interpretations. And it's important to record that, because then I can assess if this interpretation, if I believe this interpretation, what is at the back of the interpretation, or if I do not believe this interpretation. And out of these different interpretations, then there is an inference on this use of this so-called Mitterberg process. What's very important are the thesauri, like we've seen already before. We started thesauri for the material remains, fieldwork, and interpretations. And we applied them to the different data sets. And the method of doing that, the main idea was based actually on the rear backbone thesaurus. This gives certain fundamental facets where you try to organize your terms in. And the idea is not so much to make an idle alignment of the terms, saying this term is exactly the other term, but it's important. Okay, this term is a subcategory of another term, and then I can always I can always question this upper term, and I will get all the other terms maybe coming from different data sets and maybe with slightly different meanings, but the retrieval is still possible. So this is in this theory backbone thesaurus, the idea, and is represented with scars. From the semantic workflow we are doing, we are having the tables and databases with the thesauri. We are using we make a mapping to the ontology. In this case, we use the Karma tool, mapping tool, put it into a knowledge graph in a triple store. And for showing some of the results, we just made a Sparkle query, created a denormalized data set, and put it into GIS visualizations to have to explore the data and to see if the data is good, if we have any problems, and show some of the results. But of course, there are different ways to access this knowledge graph and to make use of that. And here, so for example, we integrated the sites of all these 3 institutions that were related to the project. This is so an overview to the site. Then the next thing are the material remains. In this case, we have the structures. And from the materials remains, then we look into but what's interesting is that behind each of this symbol, you have this network. You have this knowledge graph which is behind and related to the fieldwork which was done there and to the measurements which were done there on these material structures. And then, for example, here we have a look at the dating, what type of dating was used, and we already also see that there's a temporal change from coming here from the Mitterberg going down to the Oberhalbstein in the later period. So this represents the hypothesis in the data. The hypothesis is represented, and it can be queried. I can query now what is all this based on? What is the hypothesis based on? And we have just looking into the details, for example, here in the lower in value for the dating. And the next step is after the analysis is the interpretations, the periods. We see that we move here from the Mitterberg. Here we have only the rough estimation of the Bronze Age, but then it goes down to the Oberhalbstein in the early Iron Age. So the period is an interpretation based on analysis, and then it depends on what analyses were used. And this decides how much do I believe in this interpretation of the period. And then we have also an overview of the activities, of the ancient activities which were done at these sites. For example, here we have the smelting, and we have divided into the melting, slag processing, and roasting. And one advantage of this data representation is that I can query the upper terms. For example, show me all the smelting activities, even though they are, for example, they're slag processing or they are roasting. And this is not like a string comparison, but I really access the thesaurus on an upper level, and I say, give me back all the assignments which were on a lower level, which gives lots of capabilities to this data representation and the possibilities to query my data, my knowledge graph. And so the conclusion of this work is it was important to make this differentiation between the material remains, the field work, the documentation, and the interpretation, to have the provenance of the data, and using this linked open data approach with CIDOC CRM extensions enables us to represent these complex relations and the reasoning that we have within our archaeological interpretations and hypotheses, in this case applied to the spread of the Mitterberg process. Thank you.